take a look here. All right, manufacturers already has an annual demand of 16,600 cases of sugar. Cost $5 to store one case for 1 year, $34 in setup costs to produce each batch, and $16 to produce each case. Find the number of cases per batch that should be produced to minimize the cost. So there is an equation for this, and I don't know the equation, so I'm gonna look it up real quick. But it's one that's just used in this class for this type of demand.
Okay.
All right, so let me see if I can find that formula for you. You'll have to know the formula for the test. So they call it the batches of sugar annually. So this it's called the EOQ formula. EOQ. And it's the square root of the square root of 2 times demand times S over H is the holding cost. So I believe it's that. And then we'll get to the other number, I believe. Let me just check one more reference here. I haven't done one of these in a while because it's only in this course that you end up needing it.
Oh,
All right. So then, yeah. All right. This is it. So it's the square root of the demand, which is 16,600. The setup cost, yes, that 34 is the setup cost. That's S. And then the holding cost is the price on the, I'm sorry, they called this the holding costs. So over 5. And sometimes this works out really well. Is a nice number. This one doesn't say it around.
No.
I think that gives the wrong number. Huh. Well, it's 16,000. Oh, 660. I used the wrong number. That's a 60. Can't even read my own writing. Still doesn't work out. All right, there it is. Okay, so it ends up being 476.
Okay.
And it's not too bad. The number of cases per year for part B, it's another formula here. It's not as bad. It's the demand over the Q. So it's the 16,660 over the number we just calculated, 476. Which ends up being 35. Any questions on that?
No, I just gotta
Okay.
memorize.
All right, so let's go to the next one here. I think it's elasticity of demand, which is more formulas. This is the part of the course where students are like, I wish I could go back to derivatives. It's a lot easier than this. So the elasticity of demand formula, E values of Q if any total revenue is maximized. Okay. So again, there's another, you've got to grab this formula. So it's, oh, this is not what I wanted. So sometimes I send a reference sheet for this, but you don't get that on your test. So it's the elasticity formula is dq dp, which means to take a derivative of this with respect to p, then you multiply by p over q. Okay, which maybe looks weird, but that's That's what it is. So the derivative of this, if we just rewrite it, it's 40 minus 1/3 p. So the derivative is just minus 1/3. That's the dq dp. So our elasticity formula is minus 1/3 times p, and then q is this 40 minus p over 3. I think we have to solve this. I think we have to solve this for p. Yeah. No, I guess that's okay. So what I don't know, and I don't know if you can you try just one part, or does it check the whole thing?
It checks the whole
Oh,
thing.
it's at the end, right?
Yeah.
All right, let me check a reference on this, because I don't know if it'll take this as is or if we have to do anything else. So give me just a moment. What's weird is they don't give you anything else. There's also a negative. That's the other thing. I guess I didn't write that down. There's a negative here, so this is negated. Um, all right. I guess we can do a small simplification on this. So it ends up being p over 120 minus p. If you multiply the 3 into both, it cancels with that. The two negatives cancel. That's your part A box. Is that okay? Sort of. All right, so then to do part B, to maximize total revenue. So revenue, there's a couple ways to do revenue. Revenue is price times quantity. So in your problem, it's price times that quantity function, which is 40 minus p over 3, like that, which ends up being 40p minus 1/3 p squared. So you can do this a couple of ways. You could graph this and figure out where the max is, or you can use the whole calculus thing where you take a derivative and set it equal to 0. Um, how do you think you might proceed?
Probably graphing.
Okay, graphing it is just fine. So let me do a quick. Did you end up on the test doing a lot of graphing?
Yeah.
Okay, so we can stick with that idea. Minus 40x minus, I am all over the place today. 1/3 x squared. All right, so I'm graphing this in another window. The vertex is at 60, 1200. So 60 is the value of p. And then to get the quantity, you have to put it back into the quantity equation up here, 40 minus p over 3. So q is 40 minus p over 3, or 40 minus 60 over 3, which is 20. And so that's the answer here for part B.
Okay.
Some of this will go faster. The first couple are kind of slow.
Okay.
All right, so next question here. They give you this function here. Sorry, just the snip didn't come out very good. It's kind of grainy. Let me see if it's better on this other screen. Wow, they use a lot of comments. Okay, they're telling you the price. They're telling you the price is 41, and they're giving you the function up here. So elasticity is minus dq dp, so the derivative, times p over q. All right, and they give you P, so that P is actually the number you're going to use there. To get Q, you put that P value into the function. 2,247,547, 41 to the power of minus 0.04. That'll give you the Q value, which it won't mean much, but it's a Q value. That's the bottom here. And then you have to take a derivative of this, and then you evaluate the derivative at the P value. So the derivative of this thing is minus 0.04 times, it's just power rule, 2,247,547 e to the minus 1.04, because you subtract one from the exponent. And then you put this 41 back in for that. So this is the dq dp. And so let me grab a snip of this, or grab this. So you put that 41 in there, and then you combine those three numbers. So the first number dq/dp comes from this. You have P, and then you have Q here, and then you put it all together, and then you round. So what I don't know is why there's two boxes here. The elasticity of demand for oil is, and then is for 40. I guess they want you to do the formula here. I think. Let me just quickly check. All of these are in JEG, by the way. If you've not used that before, you may consider it's useful. Never the same numbers though, but
The same type
doesn't
of
help you much on the actual test.
That's good to know.
What I'm trying to look for is, like, is the first one an actual equation, or is it just a, and I can't tell. Let me look at one more reference. Yeah, so I think it is an equation, which is awful. Okay, so the first box, let me grab a snip here. Grab that. Okay, so for that first box, it's this with a negative out in front times P over, and then it's the original function here with a P instead of that. So let me actually, I can just grab it from right here. Okay, so it's 0.04 minus 0.04. Okay, so this is the first box, but we can simplify a little bit and make it cleaner. This cancels with this, and then you end up getting, oh, it does just work out. Okay. Oh, that's amazing. So it ends up just being 0.04
Okay.
for that first box, which means it actually doesn't depend on price, because the price goes away. So the second box is also 0.04. All right, so the issue here is that because the elasticity of demand is less than 1, there's some rules for this. And I don't remember them, but it's like if it's less than 1, it's something. If it's greater than 1, something. Let me look for those real quick to give you the answer. All right, so if it's less than 1, it's called inelastic. If it's greater than 1, it's elastic. When it's less than 1, you want price to increase and revenues will increase. So that's what it's asking for here. So we know that it's inelastic, which means that as price increases, revenue increases. And if it were elastic, you want price to actually decrease so that revenues increase. What happens is you're on the wrong part of the curve. So the left side is the inelastic side and the right side is the elastic side. So you want the price to trend back or trend towards that optimal price.
Okay.
Okay, I think those are the last of those for a while. And then we kind of go back to the more of the straightforward calculus questions.
And then what was the answer for the second one? I think I
I
missed
think
it.
it's the same because it's not price dependent. We were going to do all these calculations, but I think it's the same for
Okay.
both.
Sweet.
Okay, the next one is this implicit differentiation. We're going to just slightly rewrite this 2x to the 1/2 power plus 6y to the 1/2 power equals 7y. No calculus yet, just rewriting that. Now the derivative with respect to x, because the first one is x, is the same as always. You bring that 1/2 down in front, that exponent down in front, you multiply by the coefficient, you subtract 1. So it ends up being x to the minus 1/2 power. For the second one, it's you again bring that 1/2 down times 6, that's 3y to the minus 1/2 power. But whenever you have a y, its derivative includes a dy dx. So that's the difference. You
Okay.
treat y like x in terms of taking its derivative, but then you have to always include a dy dx. The derivative of 7y is 7, but then you have to include a dy dx. Okay, if you have no idea what I'm talking about, that's, we'll do a few more examples and hopefully it'll become clear.
Right.
This is this procedure. The next thing is that you want to solve for dy dx. So you have to get them on the same side. So I'm going to move all of this to the right here by subtracting. So it ends up being x to the minus 1/2 equals 7 dy dx minus 3y to the minus 1/2 dy dx. And then you factor out the dy dx, which looks a little weird, but this is what you're asked to do. And then you divide both sides by what's not the dy dx, because your goal is to make them the same, or get dy dx by itself. So you have to undo. This is like your requisite stuff. So dy dx equals x to the minus 1/2 power over 7 minus 3y to the minus 1/2 power, like that.
Okay.
And that is it. That is your full answer. Now you could clean it up a little, but that is the full answer. We've not really been able to do anything yet where you can use your calculator.
Right.
So I'll let you know when that's possible.
Okay. Yeah.
Any questions on that?
No, got that one down.
All right. Okay, this one wants the tangent line, which is the y minus y1 equals mx minus x1. You'll remember from before, m is the derivative, dy dx. We already have an x1 and a y1. So we just got to find the derivative of this thing, which is what we were doing in the previous problem. So the derivative is x squared is 2x. The derivative of y squared is 2y dy dx. So just like it's just like x squared. You take the derivative of x squared, that's 2x. Y squared is just like x squared, except you have to add in a dy dx. 25, derivative of 25 is 0. So when you solve for dy dx, you're moving the 2x over to the other side. So it's minus 2x, and then you're dividing by 2y on both sides. So dy dx, those 2's cancel, so you get minus x over y. Okay. So to get the slope, you have that point minus 3 comma minus 4. Minus 3 over minus 4 ends up being minus 3 over 4. That's your slope. That's your m. So you go back to the box there where it says y equals, and you're just putting these into that y minus y1. So y plus 4. Well, you already have that. So I'll come back to that. Can't do that. So it's y plus 4 equals minus 3/4 times x plus 3. And then you solve for y. So you just subtract 4 from both sides. Y equals minus 3 over 4 times x plus 3 minus 4, and put that in the box there. There you have it.
All right. Okay. Got it.
All right. So next one's essentially the same, except they don't give you as much information. So you have to find more of it. So it says find the equation of the tangent line. So again, you know that it's y minus y1 equals m x minus x1. This time though, they just give you an x. So you actually have to put that into the equation first. So you got 4y cubed plus 1y minus y equals 108. And yeah, I have no idea how you are supposed to solve this. Um, the like the thing that comes to mind here is like you would try some y values. Like if you tried y equal to 3, you would find that it worked. I don't know how you as the student are supposed to be able to do this, but 3 cubed is 27. 27 times 4 is 108. Plus 3 minus 3 does end up being 108. I mean, this probably isn't going to be on your test, but like you said, it was a lot harder than you thought. I don't know what to say. But there's the point. You could graph, like if you were to graph this original function, it's going to have some shape, and then you could see where it hits 108 as well. So that's like in the previous problem, they gave you the ordered pair. They gave you x and y. That was nice. And this one, you have to find it. It's more work. All right, so now we're ready to take a derivative.
Okay.
So this is where it gets bad. Derivative of 4y cubed is 12y squared. That's power rule. But when it's a y, you have to add on a dy dx. With the xy, let me do it in blue here. You can see what that is. Like some students, they kind of memorize this. It's still product rule. It's a little weird because it's x and y. So it's first times the derivative of the second. Derivative of y is 1 times dy dx plus the derivative of the first, which is 1 times y. So this simplifies to x dy dx plus y. That's the derivative of the inner one there. So some students memorize that. You do tend to see it a lot. Then you have the derivative of y, which is minus 1 times dy dx equals derivative of 108 x to the fourth is you have to use power rule 4 times 108, 432 x cubed, like that. And then from here, you have to solve for dy dx. So you move the non-dy dx terms, which is just the y. Everything else has a dy dx in it. Right. And then you factor out dy dx. you get 12y squared plus x minus 1. And then you divide by this thing in parentheses. So you need that x and y because that you have to put them into this. That's why we found it first. We know that x is 1 and y is 3. So we put that ordered pair in here. 432, 1 cubed minus 3. 12 times 3 squared plus 1 minus 1. Definitely go into the calculator on this one. 2 minus 3 over 12 times 3 squared. Doesn't even work out nicely. All right. Does this seem overwhelming?
Tiny bit.
Yeah. I mean, I'm not eager to work through these. Just, you're getting kind of a tough batch of problems here. Let me double check that this is the right derivative since this is graded. I mean, there's a million calculators online, but they don't help you on the test. Yeah, you gotta fortunately have to muddle through xy minus y. All right. Let me just double check that this is right. 432, or was that 432 x cubed minus y minus 1 plus x? Yeah. Okay, this is correct. Wait, it's x is 1, right? Y is 3. 432 minus 3 over 12 times 3 squared. Yeah. Okay. Well, this is what it is. So now this is the slope. So the equation is y equals 143 over 36 x minus 1. And then y is 3. So you would add 3. That's your final answer on the right for that. But wait, there's more. All right, there's another one of these. Let me know when you
Okay. I put that in.
sorry, question.
Oh no, just I said I put that
Okay.
in.
Okay. All right, so here's the next one. It doesn't look that bad, but now that's for the second derivative. So you end up doing like what we just did. Uh, so there's like two parts to this round. The first is you basically replicate what we've been doing, which is you take the derivative, 14y dy dx equals 0. And from here, there's two things you do. The first is you actually end up taking yet another derivative, which we'll do on the right here. And then on the left, you actually solve for dy dx, and you'll see why in a moment. So on the left, on the right here, the derivative of 10x is 10. The derivative of 14y dy dx ends up being product rule. You can see that this is make a note of that as a product. So it's 14y b squared y dx squared. This is keep the first, take the derivative of the second. Derivative of the second is the second derivative, plus the derivative of the first, which is 14 dy dx times dy dx equals 0. And so you get 10 plus 14y d squared y over dx squared plus 14 dy dx squared equals 0. And it looks really bad. But this is the thing on the right. We're going to solve for this d squared y dx squared. And then we're going to substitute in the derivative here. So just a lot of algebra at this point. So you're basically solving for d squared y over dx squared. So it ends up being 14y d squared y over dx squared equals, so you move the non-terms over, and then you divide by this 14y. So your d squared y over dx squared is minus 10 minus 14 dy dx squared over 14y. And then you need dy dx. So you go back to the previous part here and you solve for dy dx. Subtract the 10x, divide by the 14y. So your dy dx is minus 10x over 14y. That's what goes in here in this dy dx. So it's minus 10 minus 14, and you're squaring it, the minus 10x over 14y squared over 14y, like that. And Pearson might accept this, we could simplify it a little. It kind of feels like we should, but I don't know.
Okay.
So do you want me to just go a little bit further and simplify this?
What was that? Sorry.
Do you want me to go a little bit further and simplify this? Because I don't know if it should take this, but I don't know if it will.
Okay. Then yeah, probably just to be safe.
Okay. Yeah, and yeah, so it ends up being minus 10 minus 14 times 100 x squared over 14 squared y squared. So that cancels with that. All over 14y. And so this ends up being, you can actually end up multiplying top and bottom by 1 over 14y. So this ends up being minus 10 over 14 minus 100 x squared over 196 y cubed. And then if we were to make a common denominator, 14y cubed, you'd get minus 140 y cubed minus 100 x squared over 196 y cubed. That's your final answer.
Okay. Okay.
Okay, we're actually going to skip the next one for now.
Okay.
We'll come back to it. I want to make sure, because the other ones I think we can get through. We'll come back to that, time permitting. So
Okay.
this next one is, I don't know what number we're at, but if you want to get to this one here, it's kind of like the ones we're actually just doing. The difference in this problem is that both x and y are implicit, meaning they're functions of something else. So this time when you take a derivative with respect to x, you have to add in a dx dt. With y, it's still the same. It's still the y dt. So the derivative here is 3y squared dy dt equals 8x cubed dx dt, like that. Get rid of 54 is 0, so we omit that. So now we're solving for dy dt. So dy dt is 8x cubed dx dt divided by 3y squared. So your x is 3, so it's 8 times 3 cubed. Your dx dt is 5, and your y is 6. You're plugging those numbers in, and this one kind of worked out better than the last. So we had 8 times 3 cubed times 5 divided by 3 times 6. So it ends up being 10. I don't know why I don't know why you have to round. It says as needed. So just 10. Hopefully I didn't miss something on that.
Okay.
Let's look at it one more time. Yeah, dy dt, that's that one. 8x cubed, dx dt. It looks okay to me.
Okay.
Any thoughts on that before we move on?
Not really.
I know, it's really exciting.
Oh,
I don't know what to say. All right, cost, the manufacturer, uh, manufacturer of handcrafted wine racks to determine the cost to produce X units per month is given by this function. How fast is the cost per month changing when the production is changing at the rate of 18 units per month and the production level is 60? So this 18 is dx dt, and the units are 60. That's 60. So we need to take a derivative of this, which is 0.6x. That's the power rule, dx dt. So it's just like the previous problem. Whenever you have a variable, you have to add in a dx dt to it. So this is 0.6 times 60 times 18. And that is 648. It's positive, so hopefully there's an increasing option there. Is that possible?
yes, yeah, perfect. Increasing at 648. Okay.
All right. Can we move on to the next one?
Yeah.
All right. The classic ladder problem here. So it's a ladder is leaning against a wall of a building, lighting. So there's a lot of ways you can draw it, but the ladder is over here, and it's sliding out that way, and then it's sliding down from the top. It's a 10-foot ladder, and it's sliding away at 2 feet per second. So this is dx dt because it's the x value. And we're trying to find dy dt, and it wants to know how fast is the top of the ladder moving down when the foot of the ladder is 3 feet from the wall. So this is 3 feet. So to find y is over here. It's x squared plus y squared equals 10 squared. That's the Pythagorean theorem. So x is 3. So 3 squared plus y squared equals 10 squared. So y equals 100 minus 9, square root of that, square root of 91. And so the next thing is you take a derivative of this function up here. I actually did that earlier, but we'll redo it here. It's 2x dx dt plus 2y dy dt equals 0. And so we're trying to find dy dt. So it's when you solve for dy dt, it's minus 2x dx dt divided by 2y. So the 2's cancel. It ends up being minus x dx dt over y. And so you have all those values. Now x is 3, the x dt is 2, and y is the square root of 91. That's why it says to round. It doesn't work out nicely. So minus 3 times 2 over the square root of 91. So it ends up being negative. And this is an easy mistake to make on the exam. It's negative because it's moving down. 629. So in the question, it says how fast is it moving down? So that already accounts for the negative. So that's you would put a positive number in the answer.
Okay.
That's just a small thing.
All right.
All right, next question here. All right, a rock is thrown into a still pond. The circular ripples move outward, and so that's radius. The circle formed is changing at a rate of, so it tells you 5 here. That's dr dt. The radius is that. find the rate at which the area is changing when the radius is 13. So from a previous course, you're supposed to know the area of a circle pi r squared. The derivative dA dt is 2 pi r dr dt. So it's the derivative of r squared is the 2r. The dr dt comes from the fact that it's implicit. And so you have all these numbers now. It's 2 times pi times 13 times 5. So it's round to the nearest thousandth again. So we got 2 times pi times 13 times 5, which is 408.407. The course gets slightly easier after this quiz. This one can seem really, really, really tough. All right. We'll go to that one we skipped now, if that's okay with you. Is that okay? I know
Yeah,
maybe not
yeah.
super exciting, but just to make sure we're not just going out here. This one's awful. The I sort of just don't even think it's worth us doing this, like giving the answer, because I mean, I don't think you're gonna get this in the test, but the idea here is that dq dp is dx dy if you choose this to be p as x and q as y, if you kind of think of it that way. If you think of it the other way, which is probably how we should start it out, we should think of this as p as y and q as x. And then we're finding dy dx, which is more straightforward here. So imagine that this is really 7y squared plus 7x squared equals 1200. And we're asked to find dy dx. Okay. No, that's not right. Sorry, I'm losing my mind here. It was right the other way. Okay. Sorry, that's y, that's x. Okay. 7x squared plus 2y squared equals 1200. And now we're finding dy dx. So this is just like the ones we've been doing where it's 14x plus 4y dy dx, and dy dx ends up equaling minus 14x over 4y, which is minus 7x over 2y. But you can't use x and y's, you have to use the p's and the q's. So for uh oh boy, this is so unfigured. So the q is a function of p. You assume that q is a function of p. That's this one right there. So it's the first option. And then it's the rate of change of demand with respect to price. And it's minus 7p over 2q. It's mapping the letters back the way they were. So that's this box here. Is that okay?
Yes, then there's a second part.
The other one is basically the flip of this. And that's where this gets really confusing and annoying. So this time, to find dq, it's now 7p squared plus 2q squared equals 1200. This is now y, and this is now x, okay? And P is a function of Q this time. So P is a function. Make sure I actually chose the right one. Assume that P. So I gave you the wrong. A should be the second one. B. No, differentiate with respect to G. No, that was right. I'm sorry, that was right.
Okay.
All right. So then you just take, like, it's easier to do it with Y's instead of P's and Q's. So it's 14y dy dx plus 4x equals 0, dy dx equals minus 4x over 14y minus 2x over 7y. X is really Q. And so dp dq is the rate of change of price with respect to demand. It ends up being minus 2q over 7p. Like that.
It's
All right. Did we get through everything today?
we did, yes. Let me
Okay.
put that
Yeah, stop the recording.